We're going to go over connecting slope, variation, and first differences. So similar to what we've done, it's kind of amalgamating everything. So we've been given a setup here, some data about the number of flyers and earnings that a student makes. Okay? So each of these is technically a set of coordinates. And we need to keep that in mind when going through this. Now, the first thing we want to do is figure out if there's a linear type of relationship. And what can we use to figure that out? We can graph it. What else can we do? Yeah, first differences, because we're already really set up for first differences. Now, what's the first thing we have to check with first differences? Yeah, we have to check that the x is changing by the same amount. And is it? What's it going up by? 100. Good. So let's find out our variation change, and it's important to know the x one. So we'll say the x is 100 every time. Okay. And then let's find out our y's here. So we're going to take 61, subtract 52. What is it? 9. Whoops. That's supposed to be a 2, not a... Good. What about 52, subtract 43? 9. 43, subtract 34?
9.
Yeah. And 34, subtract 25.
9.
There you go. So we have a very constant variation here. So is this linear?
Yes.
Yes. We know that this relationship is linear. And what we're going to do is we're going to set up a graph to test this out. So we have earnings and we have number of flyers. Now we already went through it, but which of these is our x-axis?
Number of flyers.
Yeah, number of flyers. This is our independent variable, right? We make money depending on how many flyers we give out, which means our dependent variable is our earnings. So we'll call earnings, we'll set it up as dollars, and number of flyers will be our x, so we'll just call it number. Okay? What is our x going up by, or what would be a good scale to put on our graph? Yeah, if we go up by hundreds, we're probably okay. So we'll go up by 100 each time. And what about our earnings? How far do we go up to? What is our range here? Yeah, it goes up to about 61, right? And we go from 25. So this is about 40, a little less than 40. So let's see if we can go up by 10s. 10, 20, 30, 40, 50, 60. Yeah, 61 is pretty close. So that's probably a pretty good one. We'll go up by 10s with our Y scale.
Can we go by 12s?
We could, but 10 is a very even, easy number to use, right? And we always try to make our scale as easy as possible for us. So all of our points on this graph, we have 0 and 25. So that's going to put us halfway between. Then we have 134, almost halfway between. 243, probably about there. 352. And finally, 461 is probably about there. Now, we already know from our subtraction that we have a linear relationship, and it is shown with our line here. So we know these two connect. We have a linear relationship. We should also connect our slope, our rise over run, to this idea. Now, we've already talked about it once before, but we should talk about the rise, right, over the run. So how much do we rise each time?
4.
That's right. This distance here, we've already looked at it, is 9. And how much are we running, I guess you would say? We go by 100 every time. Okay? Now, is this a positive or negative slope? That's right. Anytime we have a slope going this direction, we have a positive slope. And this direction is a negative slope. So this is increasing as our x values increase. And that makes sense because both of these values are positive. And when we divide a positive by a positive, we'll get a positive answer. So let's connect it to the equation. What part of our equation, when we have y equals mx plus b, which of the variables deals with slope? I have that.
Teachers, could you please?
Sorry. That's okay. So, our slope, which of these variables? I have a y, I have an m, an x, a b. Which one stands for slope? M, that's right. M stands for slope. So, let's make our connections that we made the other day. We know that m is equal to the change in y over the change in x. And that's also the rise over the run. And there's also an equation for it. Anyone remember the equation?
Y minus y.
That's right. And we're going to test that by plugging in values. But we already know that our rise was a value of 9, and our run was 100. So our slope is 9 over 100. And we're going to verify that. Remember, we talked about with first differences, we take the y value and divide what our x values are changing by, and that is exactly the same. Our m is equal to our 9 over 100. So twice we verify the slope. And the third time we should verify it is actually putting in this equation. We don't have to verify things 3 times, but we want to make our connections. So I'm going to take just 2 points along here. We'll take these points. I'll call this coordinate 1 and this one coordinate 2. So our 2 coordinates are 352 and 461. Good. So this is our coordinate 1, this is our coordinate 2, which makes this, what is the first value, x or y? x1, y1, x. Okay, so if we go to set up our formula, remember m is equal to y2 subtract y1 over x2 subtract x1. What is my y2? 61. What is my y1? 52. Excellent. What is my x2? And what is my x1? Good, Scott. Let's subtract these values. 61 subtract 52 is 9. 400 subtract 300. So, 3 different ways we were able to prove the slope of this. 400 subtract 300 is positive 1. Okay. So 3 different ways we were able to prove the slope. So we know it's going to be y equals, for sure, m is 9 over 100. We've already figured that out. The only other thing we haven't figured out is our b. And b stands for what? The y-intercept. So if we look on our graph or at our coordinate, whenever x is 0, we take the y value. So we have 2 versions of it, and they both stand for 25. So we know by looking at this that our b value is equal to 25. So our equation of this line, y equals 9 over 100, x plus 25. Now, I want to take this information. I want to know, can I move this down? I want to know at 1,000, okay, so here's our little broken line. At 1,000, if this person delivered 1,000 flyers, how much would they make? Now, we could continue our pattern by 9s. There's a lot of work there. Or we could extend our graph. But the best way, or the easiest way to do it, we'll plug it into our formula. Because we're trying to find 1,000 flyers, X stands for flyers. We're going to figure it out right now. So what we're going to do is we're going to plug in 1,000 for that X value. And that will tell us how much we earn. Y is equal to. So Y is equal to 9 over 100 times 1,000. Hopefully you remember our fraction rules. This will become 9,000 over 100. Calm down, Phil. It's okay. If we go to divide these, we can kind of cancel out zeros to help us out. And 90 divided by 1 is 90 plus 25. So, our Y, or our earnings, is equal to $115. So if this person were to hand out 1,000 flyers, they would earn $115.
That sucks.
What type of variation is this?
Partial.
That's right. Why is it partial? That's right. It doesn't start at the origin. Good.
Bye. Have a good time.